Alright, this is 7th grade. 7th grade, 2.5, which is scientific notation. So it's page 78 in the book. Page 78 in the book. So scientific notation, I guess it best describes it right in the key concept box. So we can maybe combine the vocabulary and the key concept right here as we go. The scientific notation is best described. Let me do it as an example. We have a number 2,860,000. That's a pretty big number. It is in what we call right here standard form. Okay, now standard form means that that's how you usually see a number. We can take this and we can write it in product form, which means if I get rid of these zeros, okay, I could say that that is the same as 2, actually we could get rid of all of these, 2.86 times 1 million. Because it's 2,860,000. And scientific notation would be to take that 2.86, leave it the same, and write this to 10 to the 6th power. Remember, the trick for tens is that you just count the number of zeros. There's 1, 2, 3, 4, 5, 6 zeros right there. That's why it's the 6th power. So the rule for scientific notation, in other words, is a number has to be in the following form. C times 10 to the n, where C is a number between 1 and 10, and then n is how many places we move the decimal. So let's do some. Maybe it'll make a little bit more sense as we do some. So example 1. Joseph Keene constructed a 23-foot model of the Eiffel Tower using 110,000 toothpicks. How can you use powers of 10 to write 110,000? So there's our scientific notation. So what you're going to do is you're going to take, let me rewrite one. Okay, the idea is to make this a number. You have this form, C times 10 to the n. C has to be a number between 1 and 10. So right now the decimal point is right here. We're going to move this decimal point until this number becomes a number between 1 and 10. If I was to leave it right there, that would be 110. If I put it here, it's 11. I put it here, it's 1.1. So it's a number between 1 and 10, 1.1. And then the exponent is how many places we moved it. 1, 2, 3, 4, 5 places. So it would be 1.1 times 10 to the 5th. So now it is a number that is written using powers of 10. Okay, so let's see how they do it. They talk about the standard form. They move it 5 decimal places like we talked about. And then they wrote it 1.1 times 10 to the 5th. And they do it a little bit different. I guess I kind of skip this product form a little bit. I'm just moving it over and then I know it's 1.1 and I just count the number of places. That's scientific notation. And scientific notation is a way to write bigger numbers a little smaller. Scientists use it, and sometimes really small numbers. So here we go, our guided practice. Write this number in scientific notation. So again, I'm going to move the decimal. The decimal on 450,000 is right here. I'm going to move this decimal until it's a number between 1 and 10, and that would be 4.5. And I moved the decimal 5 places. So it's 4.5 times 10 to the 5th. That's it. So number 2, now the deal is we have to keep all the numbers on that are not zeros. 1, 2, 3, 4, 5. If I left it there, it'd be 63.1, so I got to move it one more. So it's 6.31, and I have to put those numbers because they're not zeros, times 10 to the, and I moved it 6 places, times 10 to the 6th. And let's see if it agrees. Yep. That's it. That's all you have to do. Sorry, my phone is ringing, so hopefully it's not one of you guys calling me for help. 10. See, nobody's going to answer the phone now, so we just have to listen to it ring. So I'm going to move this over 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Now somebody's going to leave a message. Let's see. Maybe someone will leave a message. So the number becomes 1. 1.0 is just 1. Times 10 to the, I went 3, 6, 9, 10. Times 10 to the 10th. Let's see what they come up with. And 1.0 and 1 is the same thing. Okay, write the number in scientific notation. Again, we're still practicing. There's a lot of these. So I go 1, 2, 3, 4, because 9.72 is a number between 1 and 10, times 10 to the 4th power. I moved it over 4 places. That's it. This one, again, 1, 2, 3, 4, 5, 6, 7, 8. So the number's 3.484 times 10 to the, I moved it 3, 6, 7, 8 times 10 to the 8th. 700. So I go 1, 2, it's going to be 7 times 10 to the 2nd because I moved it 2 places. Okay, so those should be pretty easy. Please ask if you have questions if it's not making sense. Now we're going to go the opposite way. Now I'm going to give the number to you in scientific notation. Now you need to write it in standard form. So we're going to go the opposite. Instead of moving the decimal to the left, we're now going to move the decimal to the right. This tells us how many places to move it. So it's a 7 with the decimal right there, and we move it 3 places. 1, 2, 3. Put those in. So 7 times 10 to the 3rd would be 7,000. Another way to look at it is 10 to the 3rd is 1,000, and 7 times 1,000 is 7,000. So let's see how they explain it. There it's in scientific notation, and again they wrote the product just like I did up there in 7 times 1,000, and then it comes out to be 7,000. So that works out really good. Let me get rid of some stuff here. Okay, so this one, again, I just take this number 4.398, and I'm going to move it 8 places to the right. So there's 1, 2, 3, and I still have 5 more, so that would be 5 zeros. So I put my commas in. It would be 439,800,000. See how they do it? And they take it times 439,800,000. That's the same thing I got. I think my way may be just a little bit quicker. I kind of skipped that product form. Okay, 5.2 times 10 to the 12th. Now here it gets a little crazy when you start moving the 5.2. So I move it 1, and then I have to move it 12. I move it 1, I have to move it 11 more, so that means I have to add 11 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, comma, 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 comma. Let's see, that'd be millions, billions. 5,200,000,000,000. Wow, that's a big number. So notice there's, look at all those zeros. And then there's the same number that I came up with. So we're just doing the opposite. We're now taking numbers in scientific notation, now writing them in standard form. So here's the guided practice. Number 7, we have 3.71, and we're just going to move it back 4 places because there's 4. 1, 2, 3, 4. So I fill those empty places, and it's 37,100. There's my answer. 9 times 10 to the 7th. Well, 9 has the decimal right here, so basically I just add 7 zeros. 1, 2, 3, 4, 5, 6, 7. Boy, wouldn't it be nice to add zeros on the end of a number, especially if it's in your checkbook? That'd be really nice. 90 million. This one we're going to move this decimal place 10 places because it's times, and then we move it to the right. 0.652 is the original number. So 1, 2, 3, and then to make it to 10, I'd add 7 more. 3, 4, 5, 6, 7. Put in commas. Commas make numbers easy to read. 46,520,000,000. There's our number. Okay, again, writing the number in standard form. I have 6.52, and I move it 6 places. 1, 2, and then 1, 2, 3, 4 to make the 6. 1, 2, 3, 4, 5, 6. So put in my commas, it would be 6,520,000. This one, easier, I move it only 3 places. 1, 2, 3, add the 0, 1,200. So I got to move it 10. So it's 7.126. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma, 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 every third, 71,260,000,000. There's my number. All right, example number 3, comparing numbers in scientific notation, and this is on page 79, kind of the bottom of page 79. It says, Mars has 2 moons, Phobos and Deimos. Phobos has a mass of 1.06 times 10 to the 16th kilograms. Deimos has a mass of 2.6 times 10 to the 15th kilograms. Which moon has the greater mass? So which one of those numbers is greater? So let's write them in standard form. So I have 1.06, and I need to move the decimal 16 places to the right. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I put my commas right here. Okay, well, I don't even know how to say that number. Now let's do the same thing with 2.4 times 10 to the 15th. So I move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Put commas every third. Did before. Okay, let's see how these match up. These match up. These match up. Those match up. Those match up. And the 10 is bigger. So I think it is Phobos is the biggest one. Let's see if they agree. To compare the numbers in scientific notation, first compare the exponents. If the exponents are equal, then compare the decimal parts. So there's the 16, and this one has the 15. So one is smaller. So because it's smaller, it says, because 16 is smaller than 15, or bigger than 15, that number has to be bigger. Well, that makes sense. Maybe I wouldn't have to have written those out. So I agree with them. Okay, so let's do what they are saying is you compare the one that has the bigger exponent, which would be the 22, according to what they say, would be bigger than. So we're going to go with less than. See if we agree. Yep. Well, that's an easy way to do it, so I don't have to write out those big old numbers. Now, these are the same exponents, so we go to the numbers. 5.1, 5.2 is bigger than 5.1, so it would be greater than. Well, that's a good way to do it. Okay, we compare the exponents. The one with the bigger exponent is bigger, so greater than. And then 37 and 37, notice the exponents are the same. So then you actually look at the numbers. 3.2, 3.5 is bigger than 3.2, so that one is also greater than. All right, so there's your taste of scientific notation. Good luck, have fun, and if you have questions, please ask. We'll see you next time.